Hey everybody, and welcome to a quick video on exponents. So remember from before that when we use multiplication in itself, like in the first example, 4 times 5, that's just a way of condensing addition. 4 times 5 is the same thing as saying add 4 to itself 5 times. 1, 2, 3, 4, 5, and we know that's going to be 20. And just like multiplication is a way of condensing addition, so are exponents a way of condensing multiplication. So for instance, let's look at these first three examples. In the first, we've got 4 times 4 times 4 times 4 times 4. 4 being multiplied by itself 5 times. And the way to condense that is as such. We write 4 with this little 5 up here. This is called 4 to the 5th power, and that means multiply 4 by itself 5 times. In our second example, we're multiplying negative 3 by itself 4 times. So how do we write that? We're going to write that with a negative 3 in parentheses, and we're going to raise that to the 4th power. That means take negative 3 and multiply it by itself 4 times. One quick word of caution. Note that this right here below would not be correct. I'm going to do this in another color so everyone is aware. This would not be equal to this. If we're going to be multiplying negative 3 by itself a number of times, it's really important that we have that negative 3 in parentheses. Because what this says down here is negative 1 times 3 to the 4th. And we're going to talk about that a little bit more later, but not the exact same thing, so I want to be really careful there. In our third example, we've got 2/3 being multiplied by itself 3 times. So what we're going to do is we're going to put a 2/3 in parentheses, and we're going to raise that to the 3rd power. Once again, just like with the negative 3, it's going to be really important to have parentheses around that 2/3, because if we had just this, it looks like we're raising only 2 to the 3rd power, and that the denominator 3 is not getting raised to that power as well. Similarly, if we're given something in exponential notation, so we've got an exponent, we got to make sure we know what that means. So 4 to the 2nd power, or 4 squared, we need to know that that means, oh, we're just multiplying 4 by itself 2 times for a grand total of 16. Note that we're not multiplying 4 by 2. We're not going to get 8 here. It's 4 multiplied by itself just 2 times. With negative 2 raised to the 4th power, that means we're going to take negative 2 and we're going to multiply it by itself 4 times. 1, 2, 3, 4. And we end up with, well, negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4 over here as well. And we're going to end up with 16. And last but not least, negative 5/2 raised to the 3rd power, or cubed, means we're going to multiply negative 5/2 by itself 1, 2, 3 times. And I know that when I'm multiplying fractions together, I can multiply all my numerators and I can multiply all my denominators. So we're going to end up with negative 5 times negative 5 times negative 5, which is negative 125. And 2 times 2 times 2 is 8, so negative 125 over 8. So just a word or two on terminology. Whenever we have something being raised to an exponent, the quantity down here, the number being multiplied by itself, that's called the base. And the number up here saying how many times to multiply the base by itself is called the power or the exponent. So in this example right here, 4 is the base, and it is being raised to the 5th power. The 5 is the exponent, and we end up with 1024, which is sometimes called the product. It's also sometimes called the power, but I just want to make sure that we are well aware of what we're talking about when I say this is the base, or that's the power, or this is the exponent, or that's the product. I want to make sure we're always on the same wavelength. So in these few examples coming up, let's take a look down at the bottom of our page. In our first example, 6 to the 2nd power, 6 will be our base, and that 2 will be our exponent. That'll be our power. In part B, negative 5 raised to the 3rd power, negative 5 is our base, and our power, or our exponent, is 3. We're being raised to the 3rd power. In our third example, negative 3 to the 4th power, we got to be really careful here, because what this really means is negative 1 times 3 to the 4th power. Whenever we see one of these floating negatives out in front of some quantity, it's really an invisible -1 being multiplied there. And order of operations tells us that we do exponents before we carry out any multiplication. So in this case, the number that's being raised to a power is actually 3. In this case, 3 is our base, and 4 is our exponent, and that -1 is just a number out in front that's being multiplied there. So I just want to take one more moment to talk about that distinction. Really, really, really important. We got two examples right next to each other, and even how we say them is going to be really important. For instance, in our first one, part A, I call that -3 to the 4th power. What is that? That's -3 times -3 times -3 times -3. And that's going to be 81. Note the slight difference in our second example, part B, where the -3 is not in parentheses. We have, and as I say it, I say -3 to the 4th. And that little pause tells the reader, oh, I'm not raising -3 to the 4th power. I'm multiplying 3 to the 4th power by -1. And in this case, we're going to get -1 times, well, 3 to the 4th power is 81. And we end up with -81. So a really big difference here, and one that we have to be very, very careful of whenever we're writing things in exponential notation. So I'd love to do 4 quick examples with you just to make sure we're feeling really comfortable with that distinction. So in this first one, part A, I would call this -4 to the 2nd power, and I would rewrite this before I do anything as -1 times 4 to the 2nd power, and from here should be smooth sailing. 4 to the 2nd power, we're going to do the exponent first, is going to be 16. -1 times 16 will give us -16. Whereas in this second example, we've got -4 to the 2nd power, which means -4 times -4, and that's going to give us +16. In our third example, -7 to the 2nd power, we're multiplying -7 by itself 2 times. So we've got -7 times -7 for a grand total of +49. And in our last example, we've got -7 to the 2nd power. And in that case, I would rewrite it as -1 times 7 squared, or 7 to the 2nd power. 7 to the 2nd power is 49, so we've got -1 times 49 for a grand total of -49. Another quick note on fractions. I know we mentioned this earlier, but I want to revisit it for just a moment. If we look at these first 4 examples, first concentrating on the first one, it appears here that only the numerator is being raised to the 3rd power. I would read this as 2 to the 3rd power over 3, which means all we're going to end up with in this case is 8/3, because only that numerator has an exponent being applied to it. That denominator 3, nothing happens to it. But for the second example, with the parentheses, I call that 2/3 quantity cubed. In this case, we're going to end up with 2/3 times 2/3 times 2/3. And because we have the entire fraction being raised to the 3rd power, now we are going to cube both the numerator and the denominator. We're going to end up with 8/27. So just wanted to be very explicit about that little distinction. In the third example here, -5/4 quantity squared, we're going to have -5/4 times -5/4. The whole fraction is being multiplied by itself 2 times. And we're going to end up with +25/16. In our last example, it appears that only the 5 is being raised to the 2nd power. The whole fraction isn't being raised to the 2nd power, and that negative out in front is, like it was before, just -1 times 5 squared over 4. So in this case, 5 squared is 25, and so we've got -1 times 25/4, and -1 times 25/4 is just -25/4. One other cool property about exponents, especially when we're raising positive numbers to powers and negative numbers to powers, that sometimes we end up with the exact same product. In this case, we're concentrating only on raising to the 2nd power, but what we're going to find right now is actually going to be true for any even exponent. So let's take a look at a couple examples. 3 to the 2nd power, we know that's 9. But -3 to the 2nd power, -3 times -3 is also 9. Negative 7 to the second power, well, negative 7 times negative 7 is 49. And 7 times 7 is also 49. In our last pairing, negative 5/7 times itself is going to be 25 over 49. And 5/7 times itself will also be 25 over 49. And the long and short of it is, whenever we raise a number to the second power, we're going to get the same product as if we raise that number's additive inverse to the second power. 3 squared is the same as negative 3 squared. And negative 7 squared is the same as 7 squared. And that's actually going to be true for any even exponent, but it's going to be especially helpful when we're solving quadratic equations later on to remember this property. And one last thing that I want to leave you with before we end here is, we want to have some perfect squares and perfect third powers or perfect cubes just ready at our fingertips all the time. It's going to be helpful to have these memorized, similarly to when we had memorized our multiplication tables back in the day. So here are some perfect squares that I'd really like us to commit to memory and just have at our fingertips. And here are some perfect cubes that I would also like for us to commit to memory and have at our fingertips. So I hope you found this helpful.